know what? I've been covering AI for years now, and this week genuinely caught me off guard. 2 AI models just dropped, and they've basically slapped the entire AI industry across the face. Why? Because they've proven something that big tech really doesn't want you to know. Size is no longer king. Let me put this in perspective. When OpenAI released o1 with its hundreds of billions of parameters, when Google built their massive Gemini Ultra, everyone just assumed that to get smart AI, you need enormous models. The bigger the better, right? Well, 2 universities, one from the US, one from the UAE, just proved everyone completely wrong. And here's the kicker. Both models are completely open source. That means you can download them, run them on your own hardware, no API fees, no restrictions, no corporate overlords deciding what you can and can't do. But before we dive into the technical details, let me explain why this is actually a massive deal. Right now, if you want good AI reasoning, you've got a few options. GPT-4 will cost you $20 a month with message limits. Claude 3.5 Sonnet, same deal. And o1 Preview? Even more expensive with even tighter restrictions. They all share one fundamental problem. You control absolutely nothing. OpenAI can raise prices tomorrow. They can ban your account next week. Their servers go down, you're stuck waiting. But these 2 new models? They just changed the entire game. Let's start with the first one from Brigham Young University. It's called ERA 4.5 21B A3B Thinking, which is admittedly a mouthful, so let's just call it A3B. The architecture behind this thing is honestly brilliant. They're using something called Mixture of Experts, or MOE, and while that sounds complicated, the concept is actually pretty simple. Instead of having one massive model doing everything, they have multiple smaller experts, each specializing in specific tasks. Here's how it breaks down. 21 billion parameters total, but only 3 billion are active at any given time. There's this smart router that decides which expert to activate based on what you're asking. Why is this approach so clever? You get the power of a 21 billion parameter model with the speed and cost of a 3 billion parameter model. It's like having a team of specialists where you only pay for the one you're actually using. That's engineering brilliance right there. But what really impressed me is the context window, 128,000 tokens. To put that in perspective, you could feed this thing an entire novella, 60 pages of PDF documents or your complete code base, and it would remember everything without getting confused or forgetting like other models do. Now, you might wonder how they managed this without melting GPUs. They used a technique called progressive scaling. Instead of jumping straight to 128K tokens during training, they started at 8K, then gradually increased to 16K, 32K, 64K, and finally 128K. It's like teaching someone to lift weights. You don't start with the heaviest bar. Here's where it gets really practical though. A3B doesn't just chat with you, it can actually do things. We're talking API calls, running code, interacting with databases, using external tools. This isn't just a chatbot. It's a foundation for building real AI assistants that can actually accomplish tasks in the real world. And the best part? They released it under Apache 2.0 license. That means you can use it for free, modify it however you want, and even sell products based on it. No weird restrictions, no corporate strings attached. Just pure freedom. Now let's talk about the second model, K2-Think from MBZUAI and G42. If BYU went the sparse route with their mixture of experts, MBZUAI took a completely different approach. They started with a dense 32 billion parameter model, specifically Qwen 2.5 32B, and then applied what I can only describe as the most sophisticated training pipeline I've seen. 32 billion parameters might sound big, but compared to GPT-4's estimated 1.76 trillion parameters or Claude 3.5's several hundred billion, this is still relatively tiny. Yet somehow, it's competing toe-to-toe with these giants. The secret is in their 6-stage training pipeline. And honestly, it's like watching someone teach a child to think step by step. The first stage is called long chain of thought fine-tuning, which basically means they taught the model to show its work. Instead of just spitting out answers, it has to analyze the problem, make a plan, execute each step, and then verify the result. But here's where it gets really interesting. For the reinforcement learning stages, they introduced something completely new called verifiable rewards. Instead of just relying on human preferences, which can be subjective and inconsistent, they built a dataset called Guru with 92,000 prompts covering mathematics, coding science, logic, simulation, and data analysis. Every single answer can be objectively verified as right or wrong. This is huge because it eliminates what we call reward hacking, where models learn to game the system by giving answers that sound good but are actually incorrect. With verifiable rewards, there's no gaming the system. You're either right or you're wrong. They also discovered something fascinating during training. If you start reinforcement learning from a model that's already been fine-tuned too much, the improvements plateau. But if you start earlier, closer to the base model, the gains are massive. It's like there's a sweet spot where the model has enough structure to learn, but still has room to grow. Now here's what makes K2-Think feel almost agent-like. When you ask it a question, it doesn't just dive straight into the answer. First, it writes a brief plan, kind of like an outline. Then, it generates multiple possible answers and runs them through verifiers to determine which one is most likely correct. The result isn't just better accuracy, but also shorter, cleaner responses. And that's unusual because typically when you add more processing steps, you get longer outputs. But K2-Think actually gives you more accurate answers in fewer words. On AIME 2024, it scored 90.83% with responses that were 6.7% shorter than baseline. On AIME 2025, it hit 81.24% while cutting response length by 3.9%. On HMMT 2025, the score was 73.75% with a 7.2% reduction in length. This pattern holds across different domains too. On LiveCodeBench v5, a major coding benchmark, K2-Think scored 63.97%, beating Qwen 2.532b's 56.64%, while also reducing response length by 10.5%. For science reasoning, it reached 71.08% on GPQA Diamond, proving it's not just a math specialist but competitive across knowledge-heavy areas. And let's talk about speed, because this is crucial for real-world applications. With speculative decoding and specialized hardware, K2-Think pushes out around 2,000 tokens per second. That's production-level throughput, not just research demo speed. But here's what really matters. Both teams made everything completely open. We're not just talking about model weights here. MBZUAI released the training data, deployment code, test time optimization code, everything. Full transparency. That's incredibly rare, especially for models performing at this level. Now you might be wondering why big tech should be worried about two academic projects. Let me break down their competitive moat and how it's being dismantled piece by piece. Traditionally, big tech had several massive advantages. First, data. They had search logs, user interactions, massive data sets that universities couldn't access. Second, compute. They owned data centers that could train enormous models. Third, talent. They could hire the best researchers with massive salaries. Fourth, capital. They could spend billions on training runs that academic institutions could never afford. But these two models prove that each of these advantages can be overcome. For data, it turns out that carefully curated open datasets plus smart training methodology beats raw volume. For compute, efficient architectures beat brute force scaling. For talent, academic research freedom is producing better results than corporate labs with their bureaucracy and profit pressures. And for capital, smart methodology is trumping unlimited budgets. There's also the open source multiplier effect. When A3B and K2-Think are released, the global developer community will fine-tune them for specific use cases, optimize them for different hardware configurations, integrate them into products, and contribute improvements back to the community. Big tech might have 1,000 engineers, but the open source community has hundreds of thousands of developers. Let me give you a real-world example of why this matters. I have a friend who runs a startup, and he's currently using GPT-4 API for customer service. His monthly bill? $3,000. With A3B, he could run the same service on a cloud server for maybe $200 a month, or even go fully on premises with a $5,000 initial investment. No request limits, full control over data, and complete customization capability. The ROI is obvious, but it goes deeper than just cost savings. Big tech models are trained to work for everyone, which means they're optimized for no one in particular. With open models, you can fine-tune for your specific industry, add domain-specific knowledge, optimize for your particular workflow, and integrate directly with your internal systems. Then there's the data privacy aspect. Until now, using state-of-the-art AI meant sending your data to OpenAI or Google's servers. For industries like healthcare, finance, or legal work, this was often a complete non-starter. Now you can run frontier-level AI directly on your own infrastructure with zero data leakage. But I need to be honest with you about the limitations because these aren't silver bullets. A3B is currently text-only, no vision capabilities yet. The mixture of experts rooting isn't always optimal, and deploying it requires some technical expertise. K2-Think, while impressive, still needs substantial GPU memory. We're talking 48 GB minimum, which means multiple high-end cards for most people. The infrastructure requirements are real. To run A3B locally, you need at least 24 GB of VRAM. Think RTX 4090 level hardware. For K2-Think, you're looking at 48 GB or multiple GPUs. Not everyone has access to this kind of hardware, though cloud deployment makes it more accessible. There's also the support ecosystem to consider. Big Tech has comprehensive documentation, support teams, and tutorials. With open models, you're often on your own for troubleshooting and optimization. But despite these challenges, I think we're witnessing a fundamental shift in how AI development works. The trend toward academic leadership is going to continue. Universities have research freedom, brilliant minds unencumbered by corporate politics, and collaborative models that move faster than bureaucratic corporate labs. I predict that in the next 3 to 6 months, we'll see big tech scrambling to respond. OpenAI will probably release a GPT-4.5 that's more efficient. Google will push Gemini Flash harder. Anthropic will double down on efficiency improvements. But here's the thing, they're playing catch-up now. The initiative has shifted to the academic and open source communities. We're witnessing the democratization of AI in real time. What was once the exclusive domain of big tech with their massive resources is becoming available to anyone with decent hardware and some technical skill. This means startups can compete with big tech on AI capabilities. Developers can build AI products without depending on external APIs. Innovation is going to accelerate exponentially. If you're a developer, my advice is simple. Download both models and start experimenting. Identify use cases that make sense for your work or business. Build prototypes to test real-world performance. Consider a hybrid approach where you use open models for the majority of cases and fall back to proprietary models only for edge cases. If you're a business owner, start by auditing your current AI spending. How much are you paying for API calls each month? Identify workflows that involve sensitive data and could benefit from on-premises AI. Calculate the ROI of switching to open models. Start with proof-of-concept projects to validate the approach. For investors, keep an eye on academic labs. They're creating massive value that's often underappreciated by markets. Look for startups building on open models rather than being dependent on big tech APIs. Consider infrastructure plays like GPU cloud services and optimization tools. And honestly, big tech stocks might face margin pressure as AI becomes commoditized. Here's what I think is really happening. A3B and K2-Think aren't just technical achievements. They're proof of concept that efficiency beats brute force, that open collaboration beats closed development, and that smart methodology beats unlimited resources. Big tech has spent tens of billions of dollars building moats around AI technology. But moats only work when people don't know how to build bridges. Now the entire world has blueprints for building those bridges, and they're sharing them freely. This is just the beginning. If 2 universities with limited resources can achieve this level of performance, imagine what happens when the entire global community starts contributing improvements, optimizations, and innovations. We're entering an age where the barriers to AI innovation are collapsing, where the tools that were once exclusive to tech giants are becoming available to anyone with curiosity and determination. The playing field is leveling, and that's going to unleash a wave of innovation that we've never seen before. Small teams will build AI products that compete with billion-dollar companies. Researchers will iterate faster than corporate labs. Entrepreneurs will create solutions that big tech never even considered. So here's my question for you. Are we really seeing the future of AI? Or is this just temporary hype that will fade when big tech responds with even bigger models? I genuinely think these open models represent a fundamental shift, not just a temporary blip. The genie is out of the bottle, and I don't think it's going back in. The democratization of AI has begun, and I'm genuinely excited to see what we build with these new tools. The next few years are going to be absolutely fascinating.